Cluster analysis is a machine learning technique used to classify data into structures that are more easily understood and manipulated. It is a machine learning approach that centers around the concept of grouping data points together. When presented with an input, the algorithm categorizes the data points based on the presence of related qualities or attributes. It is one of the most important machine learning method of identifying and grouping similar data points in larger data sets without concern for the specific outcome. Through this session, you will learn about the practical application of real-time data taken from the handbook of statistics on the Indian states. So if you wish to dig deeper and learn more, stay tuned and learn all that you can about cluster analysis. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
We are going to understand cluster analysis, which is one of the most important machine learning methods. And this is not going to be a theory. This is going to be a practical application on real-time data. The data has been taken from the Handbook of Statistics of Indian States and Territories. And this is published by Reserve Bank of India. It is available in the public domain, so you can also access it. And the idea was to find out some key variables where the data is complete. So we had taken some few variables which I will show you in few minutes, like birth rate, mortality rate, poverty, and road length. And this is going to be very useful for Niti Aayog, which was earlier Planning Commission, Government of India, and Reserve Bank of India, for making their policies as of which type of economic development is suitable to which type of states, or which type of employment drive is to be executed within which part of a states. So like that. So one thing with cluster analysis is that it is very useful method and very interesting. Very interesting in the sense that there is always a suspense. And whenever there is a suspense, the things become interesting by default. And why I am using the word suspense, say this is a curtain on a stage. We don't know. The moment curtain is open, what is going to be there? We will have a wow feeling. Why so? Because this is a unsupervised method, meaning thereby how different it is from supervised method. I'm sure you know, just a recap, that in the supervised methods, we are aware of that there are two levels in the response variable. By and large, it's two, but it can be more than two. But we know beforehand that in the data, there are two groups or two segments. Whereas in case of cluster analysis, we really don't know that after the analysis, what will be the final scenario, whether it will be two groups or three groups or four groups. The first thing, the moment we get a data, we are willing to see that how data is revealing the information. So parallelly, I will prefer to take you to script as well, wherever it is required. Here I wanted to show you the data frame and look at this data. So this is Python's Spider. I believe that you all are working with Jupyter. Jupyter and Spider both are very good functionalities. Today we are going to see through Spider. Don't worry, both are same things. Same code, if you put in Jupyter, it will work. So either you can use Jupyter or you can use Spider. Both are same things. Look at this birth rate. And if I click here, it is arranged in an order. So with regard to birth rate, Andaman and Nicobar is lowest, Goa is lowest, and if we go towards higher side, oh my God, Uttar Pradesh, birth rate, this is denominated to certain number of population. So it is very high. Bihar is next, MP next. This is Dadar Nagar Haveli next, Rajasthan. So it's interesting to see that with regard to birth rate, how our Indian states are on a scale low to high. We'll go to mortality rate. And if I click here, then again, Goa is very low. Manipur is very low. Pondicherry is low. Kerala is low. Nagaland is low. On higher side, oh my God, Madhya Pradesh is top, then Assam, then Uttar Pradesh, then Odisha, then Rajasthan. So this is about mortality rate. With regard to power availability, and power availability is a very wonderful indication, wonderful indicator of how industrial development happens in a state. So let me click it and let's go to see the highest first. So Dadar Nagar Haveli, oh my God, 17,281. And the next is Daman and Diu. And look at the difference from here to here. It is jumped to just a half. So the number one is this, and the next highest is half of that. The third is really a surprise. It's really one third of the second position, which is Goa, and then Pondicherry. So power availability is really very much skewed. Some states or some places are very high, and if you go towards lowest, oh my God, Bihar's power availability is low, lowest in the tally. Then Jharkhand, Assam, Manipur, Tripura, Nagaland, and likewise. Roads. Roads are again a very wonderful indicator of the economic status of any state or any country. Let me click it and let me go. Maharashtra. Maharashtra is industrially very much developed state. 6 lakh 8,000. Next is UP, though industrially not developed, but geography wise, it's a big state. So 4 lakh 15,000. Assam, it's a surprise. Assam is very hilly. How they were able to prepare more roads, 3 lakh 26,000. Karnataka, yes, logic goes because Karnataka is an industrial belt. So 3 lakh 21,000. West Bengal, 2 lakh 95,000. MP, Odisha, on the lower side, Lakshadweep, Dadar Nagar Haveli, Daman and Diu, and Dadar Nagar Haveli, Andaman and Nicobar, Chandigarh, Pondicherry. Good. Let's go back to our uh, data. So it's always better to look at the data first. Here are all the four variables, and diagonally you can see their kernel density estimates, and these are scatter plots. And you can very easily see that birth rate is having some bumps, some unsymmetry here. With regard to mortality rate, this density estimate is almost uniform, smooth. So for clustering perspective, these two variables will not create any trouble. With regard to power availability, look at the distribution. Look at the right hand tails. Oh my God. It looks like that things are not uniform. And there are states which can be termed as outliers. And from clustering perspective, definitely they will create some trouble. With regard to road length, so this is smooth up to here, and then on the right tail, on the higher side, yes, there are observations. And again, this indicates that this may create some trouble during our clustering procedure. It's good to start with a heat map. So these three variables on the scale looks like same on the scale, and road length. Oh, there is a clear cut difference with regard to this variable, which is road length. Better to go for another heat map, which provides you uh, clustering as well. This, which is called cluster heat map. And if I take you to script, then you can see you can have heat map like this, and you can have cluster map like this. So this shows, this is again road length. All these three are on a scale. So they are very close. That's why they are in one same color. But this clustering, this indicates that clustering is possible in this data. And you can see this clustering is based not only on road length. This clustering is done on the basis of all the four variables. And we can see clearly there are two groups. One is here and one is here. So it is giving us a good indication, or it can be termed as a good start, where we can have the feeling that clustering is possible. Then we are going for histogram and box plots, and here power availability, and we can see clearly that there are outliers with regard to road length. Yes, there are outliers. I have made the correlation matrix also. Mortality rate, birth rate, both goes together, 0.78. Rest are very weak correlations. How K-means clustering happens. So, and this is in the context of as if we are going to make two clusters. So here is the data in circles and in triangle. Any two data points in the space are picked by your software, by Python. So green star, black star, and then allocation of each point starts happening. Say this point is closer to this, so it will be allocated to this. This point is closer to this, so this data point will be allocated to this. Once allocation is done, then this green star and black star, they are shifted to their centers of the newly formed groups. After that, again reallocation happens. This is tricky. Again reallocation happens, and let us expect that some reshuffling happens. The moment reshuffling happens, the position of the stars again changes, then reshuffling happens, positions of the stars again changes, and a time comes when reshuffling is stopped, and then the position of this black star and green star are locked, and they are called centroids, and then these can be termed as cluster 1 and cluster 2. And this is happen more than one time, say 20 times or 25 times before locking two clusters. And the same happens with 3, 4, 5, 6, 7, 8, 9, 10. Here we are starting. Always better to have a working directory. So this way we create a working directory. My working directory's name was this. It's on desktop, and these are popular libraries or packages which we are going to use. And we will import the data. So the data import will happen. We have seen this before in the past few minutes, that how is the structure of the data through um, heat maps and through correlation matrix and through histograms. And here is the screenshot. Same, we have gone through this lively. Now, what we can observe, that state is appearing as a column, dedicated column, and it indicates that it is one of the variable, whereas we want this to be indexed. Indexing should not be done in terms of 0 to 35 in this case, because there are 36 states. So we wanted this to come here. This we can do like this. We will do indexing, which is done. This is the data name, set index, and then you can see that the states are here. States reached here, they are indexed, and our four variables are here. So this we had done. We had brought states as indexed, and Uh, Before proceeding further, um, let's take a sample of some numbers, say 10. Let's pick some 10 states, and this we can do through sampling of the data, and we want to be random during our selection. We don't want that only top 10 or bottom 10 or middle 10 appears. So we will feed one random state, which is here. And uh, these are the states: Chandigarh, Daman and Diu, Himachal Pradesh, Gujarat, Chandigarh, Tripura, Mizoram, Telangana, Haryana, Lakshadweep, and we will make a distance matrix. I'm very much sure that you all are aware of that Euclidean distance is by default is the method of calculating distances. Because of the time limitation. I'm not going into that detail. However, there are more methods of calculating distances. Manhattan and likewise. But we will keep our focus on Euclidean distance. At the backend, Euclidean distance is calculated and it is presented in a matrix form. And here we can plot it. Good idea. If I take you to script, I think it would be a good idea to see the output of Python and then see that how it is done. This is the sample, and here is the distance matrix. And here we have rounded it up, which you have seen on a slide. And here we are plotting it, the distance matrix. Here it is. And this I am showing on a separate slide. So let's take the example of Gujarat. So Gujarat versus Gujarat, obviously, the distance is going to be 0. With regard to Himachal Pradesh, Gujarat versus Himachal Pradesh, the distance is this. With regard to DD, Daman and Diu, Gujarat versus Daman and Diu, the distance is this. I'm explaining the red line. And there will be 10 lines. We will decode one line and then rest will be very much clear to us. Gujarat versus Chhattisgarh, the distance is here. Now, how we should interpret this diagram and what is the use? The use is if the lines are having zigzag pattern, the way red line is, and the way almost every line is, it indicates that the distances between two states, and if we consider all distances among 36 states, they are different and they are not same. And this further leads to the thought that yes, this distance matrix can be utilized for doing clustering. So, and there is one another visual. Uh, the diagonals are absolutely black and they are 0. Actually, they are 0. And absolutely white means that the distance is very great. Pure white, very great. Pure black, 0. And the upper triangle and lower triangle both are identical. So either you can look at the lower triangle or you can look at the upper triangle. You will have the same understanding. So let's look at the upper triangle. So if we look at the upper triangle, we can very easily see that there is a differentiation color matrix. So somewhere it is white, somewhere it is black, at some places or more places it is in between. This further indicates that clustering is feasible in this data set. So this is one indication. This is another one. Both are helping you to take a decision whether good clustering is feasible or not. Now, data is to be scaled. This I am very much sure that you are aware of. You see, this birth rate is in 2 digits. Mortality rate, 2 digits. Power availability, 3 digits, whatever we are able to see here. Road lengths, oh my God, 6 digits. 6 digits. 3,26,000. 1,79,000 for Andhra Pradesh. 2,06,000 for Bihar. 3,26,000 for Assam. 1,79,000 for Andhra Pradesh. Likewise. Now, one thing is very much clear. The statistical procedure, which is clustering here, but all statistical procedures, if they need to read this type of data where there is a huge disbalance or there is a huge difference in terms of units. This is 2 digits, digits, 4 digits, 6 digits. And this will definitely pose a problem. And for that purpose, we need to scale. I'm very much sure that you understand the meaning of scaling, and there is one another way. There are two popular ways where we use standard deviation in one, and in another way we use range. In one type of scaling, all the numbers remain between 0 and 1. And that happens when we subtract mean from each observation and divide by standard deviation. So if we follow that method, all the numbers will be between 0 and 1. And if we subtract minimum from each data point and divide by range, and range is maximum minus minimum, then we get this type of. Both are having the capacity to compress the data in a smaller band. Both are useful. You can go the earlier way or you can go this way. We had chosen here scaling. So we had done the scaling. How many clusters are good? So we plot a tree plot like this. Good idea. If I go here and this is the plot. Here we had done scaling. And what I do, I always, the moment I create a data, this can be a good thing for you all. I convert that data into data frame, data scale, for example, here. Because this is a array, numpy array. I make it like this, scaled. And one thing I'm very much sure that you can copy this data then and then take to some Excel for further playing like this. Maybe this is a new thing for you all, but try this. Whenever you get numbers or get new information, good idea, go to that particular variable explorer and then click. You can have so many options, copy it, and then go wherever you wish to. And now I can analyze. I can find the average, I can find the range, and I can do lot many mathematics with this. And then I can build my deeper understanding about uh, this set of numbers. So we had done this, and then I'm going to plot, which will give me an indication how many will be suitable. So here is the diagram, and this diagram is called scree plot. Scree plot. I'm very much sure that you're aware of this term WCSS, within column sum square. So in this data, when first cluster means no clustering happened, entire 36 states considered as one cluster, then their WCSS was somewhere around 150. The moment second cluster formed, it reached to somewhere here. Then third cluster, this WCSS reached here, and likewise. When we look at this plot, we need to see where elbow is forming, elbow, and or the turning point. So the turning point is somewhere here. So elbow approach is one, turning point approach is one. Second perspective, another perspective which you can have, where the reduction is less. From here to here, reduction is large. Here to here, still large. Here to here, yes, large. Here to here, lesser large. Lesser. So reduction is lesser, meaning thereby we need to stop somewhere here. So this is giving one idea that it would be good if you go for 4 clusters. Here I would like to give you one industry perspective, which is very important, which you can note down in your copy and pen. I always suggest that whenever you attend webinar or even your class, you should have a copy and pen and take notes. So my humble request, take notes. So one thing, that clustering is somewhat unstable. You may show surprise. It is not like our linear regression or like our logistic regression or like our decision tree up to some extent. It is not stable, meaning thereby, if you run the script again, you may find little variations here and there. So keep this thing in mind. This is a very, very unique feature with regard to clustering. The second point, you are making clustering for whom? If I have done this cluster analysis, then I have not done this cluster analysis to please myself. I have done this cluster analysis to give additional edge to decision makers. And who are the decision makers? These people. Always keep in mind that your beneficiary is more important. With regard to clustering, it is more important because whatever you are going to make or whatever you are going to conclude, that should give edge or give help to the beneficiary. So we will say, as a machine learning or data scientist experts, that sir, 4 clusters looks optimal, but the final number will come from the beneficiary. If Reserve Bank of India says that boss, your statistics and mathematics and machine learning and data science says 4, but we had decided that we will make policies only in 3 versions, so we need 3 clusters. That's it. So this is very, very important from industry perspective. Huh? Very important. That finally we have to listen to the beneficiary. And whatever beneficiary says, we need to incorporate. We should not work in solo. Huh? And we should not stick to the point that my script plot says 4, so we should go for 4. No, not like this. If your beneficiary says that no, India is so huge, we cannot make 3 versions of policies. We can make at the max 2. So just give us 2 clusters of states, 2, whatsoever your mathematics says. So these 2 things are very important. I'm repeating. Number one, that this is somewhat unstable. It is a exploratory method, not a model, the way support vector machine, fuzzy logics, genetic algorithm, your RNN, CNN, deep learning, TensorFlow, Keras. No, this is not that game. This is still in the exploratory stage. So keep this thing in mind. Good. So now applying clustering, it's damn easy. K-means is the function or the package or the library. You have taken the clue that 4 would be good. So you will keep number of clusters as 4 and just create your algo or create your method and then fit this method to your data. And mind it, your data should be scaled. So data is scaled and you are fitting clustering. So 4 clusters are formed. You all are aware that Python's indexing starts from 0. So 0, 1, 2, 3. Later on, we will add 1 so that it doesn't bother us what is 0 and there should be 4, why 3. So we have added 1. We can list them and we can see that now, and we have added one more column. This is here we are adding one column to our data. So Andaman and Nicobar gone to cluster 1, Andhra Pradesh gone to 2, likewise. So cluster 1. So these are somewhere around, I believe, 18, 20 clusters, 20 or 18. So these are 18 clusters. Look at their average, look at their numbers. And the average is average of birth rate for this cluster, average of this, average of this, average of this is called cluster profiling. So cluster 1 will have these averages with regard to these 4 variables. Cluster 2 is having 11 states. Cluster 3 is having somewhere around 5, 1, 2, 3, 4, 5, and big states. Maharashtra is big, Karnataka is big, Tamil Nadu is big, West Bengal is big. Kerala is not big, but as per our statistical procedure, it is following in this cluster. Good. Cluster 4. Daman and Diu and Dadar Nagar Haveli, purely because of power availability. Because of that factor. That's why we had spent time in understanding data in the beginning. And you all are data scientists, you know that you, before going for making a model or before jumping to a model, you should spend good amount of time for understanding your data. 50% of the issues are resolved here. If we would not have spent good amount of time there, definitely this question comes to your mind. Oh my God, why only these two states are forming a dedicated cluster? Now, as you had spent good amount of time, you know that these are so unique, so different from others. And that's why this is like this. This is cluster profiling. I said averaging of all the variables. And you can plot it. You can see. And this is something when somewhere was talking about whether clustering was done nicely or not nicely, whether it was overfitting, underfitting, or how to judge whether we are on the right track, whether we had done a good job. Oh my God, these are very valid questions. It is not linear regression where our R square will suffice our purpose, whether we are good or not good. It is not classification where precision, recall, F1 score, and your classification matrix will give you indication or your ROC curve. Here we need to find out something else, and that is synopsis score. So if A is the uh, data point and we want to find out Selaute score, which will ultimately give you the indication whether this is correctly clustered in this group or it should be in this group, then we need to calculate its average distance from A to all data points, which we have done here. Average is 6.85, and the average distance of this data point vis-a-vis all the data points available in that cluster. As there is only one, so there is no need to go for averaging. So we are saying it's 1.41. So this minus this divided by this is 0.79, zero point 0.8. So A is very nicely clustered. The same thing I had done here. So this is first cluster, second cluster, third cluster, fourth cluster. And you can see that we have calculated for Andaman and Nicobar. So what we have done, Andaman and Nicobar, and all these data points are scaled. So distance of Andaman Nicobar with Arunachal Pradesh, Chandigarh, Delhi, Goa, we can calculate the distance, which is this difference square, this difference square, this difference square, this difference square, summation and square root. So we are having all the values and their average. Similarly, here I have kept my cursor. You can see Arunachal Pradesh, Andaman and Nicobar versus Bihar. So this minus this square, this minus this square, this minus this square, this minus this square, addition and square root, you will get this value. And then average of all these numbers. Average of these two numbers, average of these two numbers. As you can very easily see, this Andaman and Nicobar or this cluster is very near to fourth cluster. By looking at these numbers, this is the smallest. So this minus this divided by this, and you will get 0.5369, which is the number here, this number. So this is the way you calculate Silote score, and this way we had done uh, clustering with 4 clusters, and this is also very interesting. We have found Silote scores for 2 clusters, 3, 4, 5, 6, 7, 8, 9 clusters. And we will look at these numbers as this is the highest. So this is indicating that we should go for 3 clusters. Few minutes before, we had seen that our scree plot was suggesting that we should go for 4 clusters. So we had gone for 4 clusters. Now, this comparison of Silote scores is saying that zero point 0.4 maximum will come at 3 clusters. So what we have to do? We have then done 3 clusterings, and we had compared Silote scores with 3 and with 4. When we were doing 3 number of clusters, one more state, Karnataka, was found negative in terms of Silote score. But look at this number. This number is very small, 0.00495, very, very small. So it means what? It clearly indicates that Karnataka was at border. So border with regard to clustering. And we can ignore all these 3 numbers as they are small. And there is the comparison. You will not see this chart in any YouTube, any PDF, any PPT on net. This is very much original and innovative, where Silote scores are compared with 3 clustering and 4 clustering. Blue stands for 3 and orange stands for 4. Now, you can see that spikes are upside with regard to blue line. And this indicates that in 3 clusterings, Silote scores were better and they were improved. So we will conclude that 3 clusters are going to be good, can be set optimum, and in support, we can forward that average Silote score was higher as compared to 4 clusters. And in 3 clusters, there were 3 states which were having negative Silote coefficient, but the magnitude was ignorable. We are going for applying hierarchical clustering now, and linkages. So there are 4 methods of linkages. One is word, single, complete, and average. We'll go one by one and see that how clustering is happening in this data set. So we have gone with word, and now a new term will come, and that is cophonetic correlation. So it was 0.66 and 3 clusters are formed. I am sure you will be able to recall what is 7 and 8. It's the same 2 states or two places where the power availability was very high, number 1 and number 2. So Dadar Nagar Haveli and Daman and Diu, these are 7 and 8. With single method, oh, look at this. Cophonetic correlation improved 0.66 to 0.76, almost 10 units, but clustering is not impressive. So uh, those who were in favor of hierarchical clustering can see that it is oversimplified. My God, only Daman and Diu is kept away, and Dadar Nagar Haveli, and rest all 34 are in one place. It's oversimplification. So Pilote score is not for test of normality. My dear friend, kindly don't bring the concept of normality here. Normality is a big issue, different issue. No way connected to clustering. Huh? Silote score, I would like to mm, take you to this slide. How Silote score is calculated. No inclusion of normality. Please make a point. Distance, average distances of A versus all the data point, which is 6.85. Average distance of the data point within cluster where it is allocated, and this minus this divided by this, which is B minus A, that is Silote score. No connection with normality. It is indicating you whether the allocation of the data point to a particular cluster happened correctly or not, nicely or not. That's it. No interface with normality and other concepts. I believe I'm clear. So is this clear, my dear? The purpose is how to judge whether A is properly clustered or not, whether B is properly clustered or not, whether E is properly clustered or not, whether C is properly clustered or not. How you will find out, how you will validate, how will you cross check. So Silote score is for that purpose. I hope I have given the answer. So single method clustering, though it looks nice if you look at this number 0.76, but clustering is not that impressive, not a good idea to have Daman and Diu and Dadar Nagar Haveli standalone because their power availability is very high, and rest all 34 in one basket. So this does not look nice. Complete method goes for 3. Silote score is dropped to 0.71, and then average method 0.81. Oh my God, 0.81. Awesome cophonetic correlation. But I will explain you that what is cophonetic correlation. Huh? Good. So, but see here, number 20 is standalone as one cluster. These 7, 8, Daman and Diu and Dadar Nagar Haveli as one cluster, and remaining as one cluster. As only one state is coming standalone like this, not a good idea. If you look at all the 4 clusterings done by hierarchical clustering, this looks nice, having cophonetic correlation 0.71. This is 0.76. This is 0.66. Though looks nice, but cophonetic correlation is weak. I will go for K-means by looking at all these. And this is me, but we will offer these 3 clusterings, particularly this, by complete method with 0.71 cognitive correlation. This looks nice, almost closer to our K-means, and this is not good. This is good, but cophonetic correlation is not that good. We are having better cophonetic correlation here. So we will go with this, and average method is also having good cophonetic correlation, but better combination. It's it's good idea to see that how cophonetic correlation is calculated. That will clarify your all inquisitiveness vis-a-vis Silote score. What I had done, I had taken 1, 2, 3, 4, 5 states as a sample so that I can show you the calculation. This is Andaman and Nicobar, Lakshadweep, Meghalaya, Delhi, and Karnataka. So this was their original numbers or original data. We need to scale. So we have scaled, and after scaling, we can present the entire distance matrix like this. So we have presented like this. Andaman Nicobar versus Andaman Nicobar 0. With regard to Lakshadweep, this. With regard to Meghalaya, this is the distance. With regard to Delhi, this is the distance. With regard to Karnataka, this is the distance. And likewise, their corresponding distances. So first, stage 1 is very simple. we need to see that distances after scaling of the data are presented like this. This table shows that this is the nearest number, smallest number. And this gives the indication that 0 and 1. In other terms, Andaman and Nicobar and Lakshadweep can be clubbed. So they are clubbed here. Remember, they are clubbed at 0.91. Second stage. Now we need to reconstruct the table. The first construction was plain, their distances after scaling of the data, and here, as Andaman, Nicobar and Lakshadweep are now one cluster, so they will be treated as one cluster, and their distances with Meghalaya, with Delhi and Karnataka, they are calculated. You know, at present we are showing this demo via average linkage. So how these three distances will be calculated? Interesting to know. Say for example, this cluster with Meghalaya. So it's easy. So Andaman and Nicobar with Meghalaya, which is 3.89. You can confirm from here. Then Lakshadweep with Meghalaya, 3.40. So it is 3.40 here. Lakshadweep with Meghalaya. 3.40. And the average of these two. So the average of these two is 3.64 to 3.64. Similarly, this cluster versus Delhi, this calculation is interesting, but pretty straightforward. So Andaman Nicobar versus Delhi and Lakshadweep versus Delhi and their average. Andaman Nicobar versus Karnataka and Lakshadweep versus Karnataka and their average. And these three numbers are mentioned here in the matrix. We will try to find out the lowest, where lowest is here. Meaning thereby, now Delhi is going to be connected with this cluster. So you see 0, 1, 2, 3. Indexing starts at 0. 0, 1, 2, 3. So Delhi is going to be connected. Good. No, we will have differences in number of allocations by K-means and by hierarchical. Different. So once this Delhi is added at stage 3, 4 is added. And what is that for? Karnataka. So here are the calculations. Now Andaman and Nicobar, Lakshadweep and Delhi are one cluster. Vis-a-vis Meghalaya, vis-a-vis Karnataka. These two distances are to be calculated. Straightforward. Andaman and Nicobar versus Meghalaya, Lakshadweep versus Meghalaya, Delhi versus Meghalaya, and their average. With regard to Karnataka, Andaman Nicobar with Karnataka, Lakshadweep with Karnataka, Delhi with Karnataka, their average. And we will look at the nearest or the smallest. Smallest is this, hence Karnataka is added to this cluster. And the last two, which is 0, 1, 2, Meghalaya. The last Meghalaya is added, but the calculation of average distance is same way. We need to calculate. We should not take 3.8 straight away. This is now the way cophonetic correlation is calculated. Look at this table. These black numbers are the distances, original distances. And then you see red numbers. How these red numbers are appearing in the typical cell. This needs explanation. So listen carefully. So what we had done in this, first Andaman Nicobar and Lakshadweep were connected at 0.91. So we will write 0.91 here. So that was our first cluster. In second cluster, Delhi was connected with Andaman Nicobar and LD at 2.66. So Delhi versus ANK. 2.66 is to be written, and Delhi versus Lakshadweep. 2.66 is to be written. Then Karnataka was connected with this cluster. So Karnataka versus ANK, Andaman and Nicobar. Karnataka versus Andaman Nicobar, 3.11 is to be written. Karnataka versus LD, Lakshadweep. Karnataka versus Lakshadweep, 3.11 is to be written. And last, Karnataka versus Delhi. Karnataka versus Delhi, 3.11 is to be written. And the last was Meghalaya, which was connected to all these three states at 3.72. So 3.72, 3.72, 3.72, 3.7. Now we are having two data series. One original, here is the original, and one, these red numbers, which are here, which are shown by manual work. And this, which I got through Python script or Python command. And you should not show any surprise, both are same. Our calculations are exactly same. 0.097, 0.90791, 3.71, 3.7, 3.65, 2.66, 3.10, 3.1. Numbers are same. And the simple Pearson correlation is 0.9451, and the same is given by our Python script 0.9451 same. So same correlation matrix and same coefficient of correlation. I have explained you that how cophonetic correlation is calculated. Let's conclude. If the data is large, definitely you should go for K-means because hierarchical clustering consumes too much of computation. And this second, whatever I have written in the middle is very important to you. As a data scientist, don't push your cluster to the customer or to the beneficiary. Don't work in solos. Involve beneficiary. Show him this cluster, which looks better from hierarchical model, and show your three K-means cluster. And seek the opinion of beneficiary. And let them take the final call. Your job is to do the work, analyze it, and show it to beneficiary. With regard to clustering, always take decision in consultation with the domain expert. However, this last sentence is valid for most of the statistical modeling and its deployment. You need to involve beneficiary because ultimately he is going to be used.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.